Okay, now let's go and code the RMS norm. And as I mentioned, for the RMS norm, I'm not gonna implement the in fact code by Kai Gomez. I'm gonna implement the same in fact the way that they did it in Mistral or LLaMA code, which you can also find it in the Mistral and or LLaMA's GitHub pages. So if you go to Mistral, so it's Mistral inference, and if you go to transformer layers, you can see technically right in here the way that they implemented RMS norm. And also, by the way, where we're going to use the RMS norm, here we have, if you remember, this architecture of the LFM2 in the transformer block. As you can see, we use RMS norm a couple of times. So we're gonna make that module for now, and then we can use it later on within the architecture. But also, what exactly, quickly, let's have a look at RMS norm and what it is and what it does. So technically, when we want to do a layer norm or a kind of normalization for a vector, and let's say this A is a vector of dimension n. So when we want to do a kind of normalization, we're gonna just find its mean and variance, and then based on that mean and variance, we can scale it or normalize that layer or vector or whatever that it is. But what RMS norm says here, which is technically a little bit better in terms of calculation and generalization, RMS norm is just simply say, okay, you have that vector, just take the square of what is it, each element of that vector, sum them up, divide them by the dimension of the vector, and then take the square root of them and call it RMSA. And then for the RMS norm of the vector, just simply divide each element by that RMSA. So that's technically what we're going to write down here. So again, we're gonna import torch, we're gonna import torch.nn as nn, and is a kind of, this autocomplete is a kind of a spoiler, I would say. But let's go import torch.nn as nn, but it makes it much easier to kind of follow through the code. But yeah, now we can define the class of the RMS norm. So this one, as you can see, the suggestion is the base code of the Kai Gomez, which is technically okay and the same thing, but I do not like it, to be honest. So that's why I'm gonna use the implementation of the Mistral. Technically, as I said, they are the same thing and they do the exact same thing. It's just personal preference. So we make the init file here, and we're gonna, let's see if the autocomplete and suggestion suggests it or not. We have the self, we have the hidden size, not the hidden size, technically in this implementation we call it dim. Dim is equal, dim is an integer. We have epsilon, and if you remember, the epsilon we had it in configuration file as well. So what we need to do, just initialize it, make the value of the epsilon. We have weight. This weight is also a learnable parameters, which is just as big as the dimension here, and it is just, for the beginning, it's just a vector of ones. And we have the norm, which norm here technically is just as we had it right here. Just pay attention to this equation. We square them all, then divide them by the length of all dimension, and then square root of them. So yeah, we can do this, and then yeah, the underlying norm is just technically the square root of the power of the two and the mean of them. And here in the mean, we keep the dimension, we don't want to lose the dimension, and the mean should be taken by the very last dimension because of the way that we give the inputs, because we have the batches, we have the sequence, and so on and so forth. We take the mean for the very last dimension, and the reason that we have this epsilon is we don't want to do a we don't want it to be 0 or anything like that, to have the 0 division, so on and so forth. And yeah, so this forward layer is also forward pass is just using the same underlying norm function, and then just add it, multiply it by this learnable parameters of the weight. So yeah, that's how the RMSNorm technically is.